Hi everyone, this is Vipin and welcome to my YouTube channel. In this video, we are going to familiarize ourselves with the concept of limit of a real valued function. Let us take an example. Say f of x is equal to 2x whenever x is not equal to 1. Now what does this mean? That the function takes the value as twice of x whenever x is not equal to 1. So suppose say I were to find out f of 2. Now clearly your x is 2 here, which is not equal to 1. So f of 2 is going to be 2 times of 2, which will be 4. In particular, what the function is going to do, it is going to check the value of x, and if x is not equal to 1, it is going to return you with 2 times of x. Let us check the graph of this function. Now since it is a linear function, it is going to represent a straight line. We know already that the straight line equation is nothing but y is equal to mx plus c. So comparing over here, we have 2x plus 0, that means m is 2, which represents the slope of the line, and c is 0, which represents the y-intercept. The graph of this function would look like, so if this is the x-axis, the y-axis, let us mark some points for reference. X equal to 1, 2, 3, 4 and so on, y equal to 1, 2, 3, 4 and so on, and not to forget our origin. Now since our line or the function graph is going to pass through the origin, it will be a straight line with a bend with an inclination of 2. That means when x is 1, the function should be 2, when x is 2, the function should be 4. Okay, so that's how a straight line is going to be. Now however, note that when x is 1, the function is not defined. The function does not take any value, or the function is not going to return you any value. For example, if you were to ask yourself that what is the image of 1 under f, so then you would not have an answer because the function is not defined when x is equal to 1. So what do we do here? To indicate that undefinedness, we put a hole or a circle here. That means that the function is not defined at 1 and it is not going to give us any value at 1 until more information is provided to us. Can we really estimate the value of f at 1? Yes, this is where limit comes into picture. So what we will do is, we are going to ask ourselves what is going to happen as x approaches 1, what happens to the function value. So since x can approach to 1 over here, so let's say we have the number 0.9, we have 0.999. So let me just put up a table here. So if x is 0.9, then what is going to be y? So it is going to be 2 times it, that is 1.98. If x is 0.999, then it is going to be 1998. If x is going to be if x is going to be 0.99999, this is going to be 1.99998. So it can be clearly seen that as x is taking values closer and closer to 1, and the y value corresponding to x becomes closer and closer to 2. This gives rise to the definition of limit, and notation wise we denote it like a limit. LIM is the short form for limit. Limit x approaching to 1 f of x, and the output is going to be 2. That means, and it can be clearly seen on the graph, as x is approaching to 1, the function is approaching this circle, which is nothing but y equal to 2. And if x is approaching to 1 from this side, that means if you take x values bigger than 1, so suppose say I take 1.01, then y is going to be 2.02. If I take x as 1.001, then it is going to be 2.002. The closer you take the values towards x, the better you move towards y. So if we take the values of x's from here, we see that the graph is coming down, moving towards this circle, and this again on the y-axis corresponds to the point 2. And that brings us to the definition of limit. So limit actually tells us the behavior of the function where it is not defined. Thank you very much. If you have not subscribed to my channel yet, please subscribe. In this sequence of videos, we are going to continue with this calculus section.